I'm Dan. I'm going to talk about cross-site scripting, modern protections, and payloads. First of all, why do we care about cross-site scripting? It's 2022. Surely this isn't something we're still dealing with, but no, it's still an issue that we have to think about whenever doing web application testing. It's something that I find in, sadly, the vast majority of applications that I do testing against. And our big concern when it comes to cross-site scripting is the fact that we've got our malicious entity that is able to interact with a web application, be able to deploy some method of malicious payload that our normal legitimate users then fall foul of, and our end game of being able to achieve session hijacking, compromising data security, application security, all the good stuff that we try and do whenever we're doing the exciting pen testing work. So just a quick refresher for anyone who hasn't done web testing for a while or is in other areas of cyber that's not specifically pen testing. When we're talking about cross-site scripting, we're talking very specifically about the ability to have JavaScript execute in a browser. We've got three key different ways that we can achieve cross-site scripting. There's either reflected, which is typically sent via GET requests in your browser, where our nice classic payload of script alert 1 script gets deployed and users have alert boxes execute in the browser. We've got stored, where, as the name defines, this is stored on a server and provided to users when they access different pages. If anyone is old like me and remembers MySpace, you'll remember Tom from MySpace, where everyone became his friend from stored cross-site scripting, where it's executable code. As soon as you go onto that page, you became Tom's friend, whether or not you liked him or not. And then we've got DOM-based cross-site scripting, which is document object model. This is the browser API. This is a really interesting kind of cross-site scripting because it's not data that is sent to and from the server. It is a payload that gets executed by the browser itself when it's rendering a page. And these are all ways that we can try and elicit some kind of action in a target user's browser. So what do we do when we try and find cross-site scripting in a web application? Well, we can either go for a shotgun approach, fire all the payloads at an application, start putting in script alert 1, start trying image source errors, start going obscure and having SVGs. These are all payloads that will try and have some kind of alert box that happens in a browser. And it is something that we see a lot of people do where testing will happen and it's the shotgun approach of fire everything, hope something sticks, and see whether or not you're able to identify a vulnerability. The problem is, if it doesn't execute, you're now in a position where you don't know if that application is vulnerable. You don't know if you're just a noob who doesn't have the appropriate advanced payloads to be able to execute that vulnerability. And fundamentally, you just don't know whether or not an application is vulnerable. And when it comes to pen testing, our key thing is being able to give that bit of information. So what should we do instead? We should really focus on the process of how to understand cross-site scripting. And this is very simple. It's the process of exploring all of our parameters our applications give us. It's a process of looking at the actual feedback we get. We're lucky that with cross-site scripting, it's a client-side attack. We get dynamic feedback from an application, and we can understand whether or not payloads are working or not. It means that we can figure out what protections are in place, and we can figure out how to develop our payloads. We can identify filtering, and we can come up with some imaginative payloads to deliver to an application we're testing. And eventually we get our proof of concept and profit by being able to compromise a application. So the wrong approach to cross-site scripting, which we see quite often, is you've got an application, you've got an ability to interact with it, you fire off that script alert 1 payload, and nothing happens, and you're screwed. You just have no ability to be able to understand, have you been able to work on an application that's fundamentally secure? Are you now going to turn around to developers and go, you know what, your secure development lifecycle must be fantastic because I can't achieve cross-site scripting? Or are these things just being filtered? And modern protections mean that things like script alert 1 are, they belong back in the 90s, to be honest. They're not fit for purpose anymore. We need to make sure that we're understanding the process of how we attack applications, how they're implementing filtering, so that we can come up with a more sophisticated way of working with an application. I have realized that I've embedded a couple of videos into this PowerPoint, which I'm now consciously aware that anyone about 5 rows or further back is potentially not going to be able to actually see. So I will walk you through what what the modern approach to penetration testing of an application should be when it comes to cross-site scripting. So we've got a very simple application that allows for users to input data, and it's displayed on a screen. This should, for anyone in pen testing, this should be a flashing light of screaming awareness that you should be thinking cross-site scripting and client-side attacks. Now, when it comes to modern payloads, what we can think about is the fact that filtering and putting things like script alert 1 and just having those things disappear do not indicate that applications are secure. We should be thinking about a level of understanding of how applications process data, and we should be looking into ways to test whether or not applications are fundamentally vulnerable, to understand whether or not we've got filters in place, we've got protections in place, and what we can do. So what we've got on the screen is just really simple, benign HTML that will have text put into header title format, bold, insert paragraphs into text, and we can see that applications are able to process this data, and then we can turn around and go, regardless of the fact that our script alert 1 just disappeared, we've got a fundamentally vulnerable application. It will take our input and it will understand what we are saying. So we can turn around and go, right, in the modern age, we're not just using script alert 1 and assuming that because it doesn't execute that this application's fine. We're able to actually apply some semblance of knowledge and understanding, and instead think sensibly about how we can approach applications that are vulnerable. Now, we can think input parameters that have been identified. Let's put script alert 1. Let's put more interesting payloads. Let's think about different HTML elements such as audio and video. Anyone who has tried things like image on error over the last 5 or 6 years will know that they're going the way of script alert 1 script. These are old school payloads that are very prevalent in blacklists. And it means that when we put this, we're in a similar situation to turn around and go, this payload just disappears. This is the importance of being able to understand whether or not applications actually process our data so that we can focus on developing the modern approach of how to identify cross-site scripting and compromise an application. So instead, what should be a process of understanding the application becomes a process of just firing payloads, and instead we go down the route of understanding we have parameters that are processing our data and are displaying it in a way that is, understandably vulnerable. Now, this video, it's admittedly incredibly small now that I realize for this audience, but what this is doing is it's putting the unique word of wiggle, which I choose to use whenever I'm trying to find cross-site scripting, because to this date, I've only found one website that has the word wiggle in its source code when I query it, and it was the BBC. Thanks, the Wiggles. But it means that whenever I put a payload into a web application, I can really quickly understand in the source code through using inspect element whether or not this data is being understood by an application, where it's being stored. And this video is currently just going through the process of trying things like script alert, embedded script, camel case, that kind of thing, because this is what we need to think about when it comes to protections and filtering. Application developers who have applications that are vulnerable to cross-site scripting, which we can understand through having heading parameters, bold parameters, that kind of data that is understood by the application, are not protecting their data and their user interface securely enough. We can turn around and use unique words to understand where our data is going and eventually find ourselves with payloads that work. And it's this approach that needs to be adopted to make sure that we're providing real value when we're conducting web application tests. Because things like script, things like alert, things like image, they all belong back in the 90s. They are being filtered, and there are too many applications that are flying under the radar of people thinking they are secure because there is not that fundamental understanding that a filter does not make a secure application. A filter is just getting rid of the bare bones and the most common of payloads that an attacker could try and use. And let's be fair, anyone who's doing pen testing in this room knows that we've got a very time-sensitive engagement when we're working with clients. Attackers don't have that worry. If they're getting text that's being filtered out, they're not going to turn around and go, well, I spent 20 minutes on that, so I guess I'll move on to the SQL injection that I found. They're going to focus on attacking user accounts and being able to figure out what the rules of the filter are, what the pieces of the puzzle are, and then be able to attack an application. So I decided that one of the cheat sheets I have for my work should be created into a tool that is incredibly rudimental, that I recommend anyone who wants to explore cross-site scripting go and have a look at. Shameless plug, I know. But we've got a tool, the great XEscape. What this does is it takes payloads that are being filtered out, like Script Alert 1, and if you do not have the knowledge or the imagination to come up with different kinds of payloads, it will then go through and provide you with a list of other potential payloads that you could try. In this example, we've got the fact that we can take our payloads, convert them to camel case, embed strings within strings. We can turn around and think maybe alert 1 is being filtered. Let's use text instead of numerical values. We can take a lot of approaches of whether or not alert is being filtered and deploy keywords such as confirm, prompt, anything that we feel like. And this is a really good tool at being able to focus on that approach of understanding vulnerabilities and being able to deploy payloads that are actually going to execute when attacking an application. So, to use it, nice and simple, again, shameless plug, but what we have is, if anyone does look at the code on GitHub, do not judge me. It is incredibly trivial, find and replace for generation 1. Generation 2 will be much more impressive. But what we have is the fact that over years of working through application testing, we can take payloads and we can obfuscate them. We can move data around. We can make things likely to bypass filters. Once we're testing an application and we find out there are fundamental vulnerabilities, we can come up with some really interesting ways of trying to attack them. And one of the things we can do, you saw the screenshot of Script Alert 1. What we have here is for things like the classic image source on error alert, we can turn around and use different HTML elements. We can use different obfuscation techniques, and we can make sure that we've got some really interesting ways to try and deploy payloads into parameters that we are 90% sure are vulnerable to attack. So what's our aim doing that? I mean, our aim is fundamentally to bypass filters. Our aim is to be able to understand that an application that will process our data and display it in bold or in paragraphs or in a header format is definitely taking our input and processing it in a way that means that it's a vulnerable application. What we can do as intelligent security professionals is leverage the fact that people accessing applications from purely a computer is a concept that belongs back in the early noughties. We all have mobile phones, we all have tablets. We can focus on an ability to create obscure payloads, different payloads, and use the fact that technology has evolved and that we can identify more ways of attacking applications by bypassing filters and using special terminology. OnTouch Start is a massively underused cross-site scripting payload. For anyone who does penetration testing, I highly recommend you start thinking about using it. This is a really trivial way of being able to demonstrate cross-site scripting without having to worry about blacklists that get deployed against users who are typically accessing an application through a browser. OnTouch Start means that whenever you load an application into a mobile phone or a tablet, as soon as that user touches the screen, they are going to have cross-site scripting execute for them, and it means that we can really display the ability to attack different people. And this is something that is not occurring in very many blacklists. I'm trying to think of any application that has actually filtered the OnTouch Start verb. It's a really effective way of being able to demonstrate applications are vulnerable, filtering is being deployed, but filtering does not a secure application make. Other things we can think about when it comes to bypassing filters, because again, this is the main approach application developers are taking. They're not making secure applications, they're just filtering attacks, is we can use a concept called data URIs. For anyone not familiar with data URIs, again, look into it. Massively valuable way of trying to attack applications. So a data URI is a string of data that essentially turns around and gives a command to an application. It is metadata and data combined in one, and we can turn around and provide commands that will be flagged up in cross-site scripting filters in such a way that applications don't understand them. This one specifically is taking the SVG payload that may be filtered due to SVGs or onload commands, and all it's doing is simply base64 encoding it and deploying it to the application in such a way that we leverage that technology to say, you're a computer, you understand what base64 is, you understand how to encode and decode, so if I give you a parameter that has been encoded, I want that to bypass any filters in place, and I want you to decode it and then execute what I'm asking you to do. Really effective way of being able to bypass filters. because it means that any string checking is just not working. Script does not occur in this payload. SVG does not occur on this payload. Alert does not occur on this payload. This is all base 64 encoded parameters, and you are telling the application, decode it, execute it. Really effective way of trying to establish whether or not cross-site scripting is a vulnerability that could be leveraged. So having things like alert 1, alert 2, yeah, lovely. We all know that's our proof of concept. Clients, end users, attackers, no one's happy with that as a method of attack. It's an alert box. It doesn't achieve anything. It doesn't do anything. Our end game is all about stealing sessions, being able to achieve some method of attack to compromise security. So other things we have to be aware of in our approach to attacking applications that have taken an approach of filtering and protecting their input variables is that when we are trying to achieve some form of session hijacking, more likely than not, we are going to use some form of quotation marks, whether or not that are single quotes, double quotes, whatever whatever payload you choose to use whenever someone is attacking an application. And this is a really simple way of developers being able to try and, again, protect applications that are fundamentally vulnerable and to staple security onto an application that has already been coded, already been deployed, and is fundamentally vulnerable. So what we can do with this is we can go back to classics from years gone by that people forget about now, and we can bring them into the modern age. And we can use standard ASCII characters to be able to bypass filters, again, that are going to turn around and say, you're trying to use quotation marks, you're trying to use some method of establishing a way to have a victim user come back and communicate with you, and I'm not going to allow that. The application is fundamentally vulnerable, but this is something that can't be allowed to happen because it will lead to user vulnerability. What we can do is we can take a really nice simple payload of something like NGS cross-site scripting with our double quotation marks that are, again, commonly filtered out in applications where security is bolted on at the end of development. And we can turn around and say, you're a computer. You understand what code is. You understand what commands are. I want to give you a payload that you will understand as ASCII characters, and you will recombine into a payload that will then be executed by the browser. Really nice, simple way of being able to demonstrate an application vulnerability. Really nice, simple way of then being able to achieve cross-site scripting in a method that achieves some kind of goal at the end of it. So, alert 1, alert 2, text box with text in it. This doesn't achieve anything of value to us. It doesn't give clients an ability to understand there's vulnerabilities here, there's concern here. What can we do? We can really simply take this kind of data and we can wrap it all up in multiple different steps to obfuscate this data and be able to deploy it to an application that will then be used to unobfuscate it, execute the code, and give us back data that is valuable to us. So what we can do is we can turn around and think about applications that are deploying filtering. Again, a lot of applications now are just bolting security on at the end, and they are only as good as their filtering. And we can turn around and say, you know what, I want to have my victim user come back to me on a port that I control, and I want them to give me the cookie value that they have. This is a common attack method for cross-site scripting. It's an ability to be able to take a victim user's session token and then be able to leverage it to compromise the entire security of that session, of that application. And what we can do is we can wrap this up in ways to bypass filtering by implementing base 64 encoding through BTOA, common library, an ability to focus on, again, obfuscation of data. Remember, filtering is all about seeing strings, seeing regexes that you are not happy with and pulling them out of data. So we can base 64 encode different variables that we want. We can then ASCII encode different payloads that we need, and we can focus on the fact that something like audio source on error, and that big long string there, is something that will be able to achieve a real tangible impact to data security and application security, regardless of any process an application developer has bolted on to the end of their development by saying, I've made an application, bugger, it's vulnerable. Let's stop hackers being able to deploy code that's going to cause us a problem. This is how we can take that kind of modern approach of identifying filters, finding out what problems exist, and being able to leverage that understanding of fundamental vulnerabilities into a way of deploying really obfuscated text, really obfuscated payloads, and achieve an end goal that will compromise security, compromise user accounts. And this is what we get at the end of it. We get, for anyone who's not done this before, anyone who's not a pen tester, anyone who is a pen tester who's never tried session hijacking, this is what comes back to us. We have an application running on port 8000 that is going to listen for connections, and we get a nice payload at the end of that, which is a base 64 encoded session token. And again, the mentality of using that base 64 encoding is to bypass any filters, both inbound and outbound, that application developers and firewalls or any network devices are trying to deploy to be able to remove our ability to attack an application. So we've got our inbound obfuscation of ASCII code. We've got our outbound obfuscation of session tokens that are base 64 decoded. And all we have to do is really simply base 64 decode that, and we've got a session token, or in this instance, a flag from one of the North Korean security labs. So this just shows that whenever we're bolting security onto application development, whenever we're taking the approach that security can be put to the end of a development lifecycle, that there are multiple steps that we can take to be able to identify fundamental flaws in security and be able to leverage that as part of a cybersecurity attack, and be able to do interesting work that can adhere to all the rules an application deploys of filtering and protection, and still leads to a successful attack and a successful compromise of data security. So what do we do about this? We've got to focus on the fact that development of security needs to be put into an actual secure development lifecycle. We can't just bolt on security to the end of application development. We can't have developers who don't understand the concerns of application security. We're all aware that it's 2022. Cloud first is the approach of most industries. Everybody wants a web-based dashboard for literally everything. The internet is no longer anything that people think of as optional, and so therefore everything, well, almost everything, is renderable in a browser and therefore a potential attack vector. And we need to focus on the fact that user input needs to be sanitized, not just filtered, but sanitized on its way in. It needs to be encoded on its way out when it's being displayed to users. We can either encode using HTML context or JavaScript context, whatever the appropriate situation is for an application, but developers should focus on encoding data on its outbound direction back to users. We need to think about things like content security policies that can focus on making sure resources aren't loaded from other environments instead of just the application that we're working with. And we need to make sure that any session token that an application uses is actually protected against JavaScript being able to pull that down for an attacker. These are all considerations that end users have absolutely no control over. And therefore, when we as security professionals, either as developers or testers or consultants, are working with people developing programs and software, we need to be addressing this, because end users have absolutely no ability to be able to protect themselves from this kind of thing. They are not in control of the code and the ingress and egress of data. They need to have that level of assurance that a secure development lifecycle has actually been adhered to. Thought resources are out there for people to think about if they're interested in cross-site scripting and how you can bypass filtering. OWASP, big one. There are a couple of really nice cross-site scripting applications out there to give people the chance to practice. XSS Game, AppSpot is fantastic. Level 3 has DOM-based cross-site scripting, if anyone is interested in that. It's an area that not everyone is particularly familiar with, and it means that you can focus on being able to execute payloads within a browser context without actually having that directional communication with the server. It's level 3, if anyone actually wants to focus on it. It's really quite cool. And there are huge amounts of payloads out there to be able to develop strings, develop sophisticated word lists of attacks that you can focus on when it comes to testing applications. Is that me or what about? I purposely haven't put the green axis here. We good? Partly because it's a shameful plug, and I will casually say it again, even though it's not on the slide deck. Feel free to take a look at it. But the key takeaway from this is that in a modern approach to cybersecurity... Yeah. Sorry. Hello? There we go. In a modern approach to cybersecurity and in a modern approach to addressing application security and web security, we need to be focusing on the fact that bolting on security is not a suitable approach. We need to focus on the fact that taking a shotgun approach of allowing people to just deploy payload after payload without fundamentally understanding vulnerabilities is not a sensible approach. And we need to think about the fact that a lot of applications are fundamentally vulnerable to these kinds of attacks. We just need to have a workforce that understands issues. We just need to have a skill set in the industry of people who understand these issues and are able to use tools like Create, X, Escape, and deploy payloads that are going to actually provide value and demonstrate vulnerabilities to end clients. Thank you. Are there any questions?
So what I've found recently is, I did a test 2 weeks ago, maybe, and this site was protected by Cloudflare, and Cloudflare was picking up all the stuff that you covered in there, on error, image, alert, everything, script was being detected, and there was a big unsubtle message coming up saying, malicious activity, you've been blocked. But what I did on that page was just put simple form, like please enter your username and password in there, and it was all in the URL. So just put that whole built a whole login mechanism that farmed credentials off to my site. And none of that was picked up by Cloudflare. And it was, there was no validation. There was no, I didn't have to encode anything or anything like that. It was literally just form and, input fields and away you go. And I think that gets overlooked. That's my point. I think that gets overlooked nowadays, is that some of the older, simple attacks are still valid. Yeah, I don't know.
I think that's a massively fair point for anyone not particularly familiar with HTML injection. It's taking the same concept of being able to understand how browsers are rendering input to be able to leverage that as part of an attack. And I think we are kind of, as you said, unfortunately older than I am. But as time goes on, I think there's too much reliance on tools and that ability to just fire off payload after payload and take the shotgun approach to see what happens. And I think one of the key things I'd like anyone who is in actual testing as a role here to take away is that the modern approach of taking that process of just firing off a shotgun approach worth of payloads and being able to test through sheer force of will does not work. There needs to be that understanding of it's working. There needs to be that understanding that the old school ways, in some ways, are the best, and that the fundamental knowledge is still there, and that no matter how much Cloudflare or Akamai or the next steps to try and protect applications from attack get implemented, that with that fundamental understanding of how these things work, you're able to bypass these attacks. And there are too many times where we're letting these things slip under the radar. It wasn't long ago that I was on a client site with a colleague who found cross-site scripting on an application purely because another consultancy had left cross-site scripting on an application page, and for love nor money could not trigger a new cross-site scripting vulnerability. But by taking that approach of not shotgunning this and going, well, does script alert one work? No, it's gone, therefore it's fine. But instead working through a process of identifying the filtering, identifying the fundamental issue. It took 5 minutes to be able to understand, this is just filtering out keywords, and it's not recursively going back and checking that. So we need to take this approach of actually adhering to technical standards and technical understanding before we start creating payloads, or before we turn around and just bin a vulnerability and go, that didn't work, therefore the application's fine. Yeah. Yeah. Yep.
I'm not sure any of the microphone, but do you think frameworks like React, Vue, do you find they make much of a difference?
Anecdotally, in my experience, yes. I'm sure some other people are going to turn around and go in their experience, not at all. I think frameworks always have their place. They allow frameworks for development are typically focused on cross-site scripting as a way of as a potential attack surface and a potential attack vector, and therefore a lot of work gets put into it. The big concern is that as soon as you start working on a framework, you know that multiple other applications are using that as well. Therefore, it's an area of interest for anyone trying to identify bypasses. And as Mark said, it's another blinky light kind of mentality of, I don't need to focus too much on secure development because I'm using a framework that's going to do that for me. Like I said, anecdotally, React is something that I've struggled to achieve cross-site scripting with some of the applications, but I don't know if that's because the developers using that framework have been particularly good, or whether or not it's just at the moment a coincidence.
So I think React has a bunch of techniques to try and mitigate.
Yeah.
But I think there is a small subsection of things that you can do that might leave you vulnerable. Do you think that's best solved by developer education or automatic tooling that scans code for those?
So I think developer education is best for that, because as soon as I mentioned, we've got reflected and stored cross-site scripting as some of the most common cross-site scripting attacks there are, but DOM-based cross-site scripting, where you're leveraging the actual browser API itself, is something where any over-reliance on technical solutions to turn around and say, well, when you give me this data, start stripping out keywords, start deploying it this way, start making sure that it's not imported into this parameter, can start to fall around. I mean, DOM-based cross-site scripting is a method of being able to allow a web application page to load, and then be able to provide it with a payload that will execute on that load. So the server itself never even gets the chance to do it. You're almost entirely client-side protection, which is fundamentally flawed because you're manipulating what you're giving it on a client side. And I think, therefore, that over-reliance on tooling is going to potentially be an issue. But the software developer education means that at least there's going to be an awareness of anything web first, anything internet facing is going to be attacked. So think it through. Think about any input.
Okay, thanks.
No problem. Yep.
Do you ever put any tokens within your XSS payloads so you can try and track where they were injected? Quite often I've had a large website, limited time like you mentioned earlier, and yeah, you've got a bit of a shotgun approach. You're smashing all the input values. You stop doing XSS testing because you couldn't find anything. 2 hours later, you get an alert one. You think, shit, where's that come from? Yeah, and now you've got to try and trace back for all the different places you injected alert one. Do you ever do anything where you alert AAA, AAB, AAC, so then you can start to track back where the injection was? So
if I've got a huge application with a lot of different potential vulnerable parameters, then yeah, that's when I start to make sure that I've got some understanding of this payload is going to achieve this is going to do that, so I can get an understanding of specifically which one was triggered and when. Things like document domain instead of document cookie are good ways of being able to get an understanding of what domain actually executed this. Was this data just passed off to something else somewhere else that then executed that? And to get a bit of a better understanding. It's not something I've had to be overly concerned about. I've personally not had one where 2 hours later suddenly data starts flowing back to me. But making sure that, the different parameters have different payloads, and using things like document.domain instead of document.cookie can be really helpful to understand where things are being processed.
So I've seen it before on different privilege levels within applications. You might have one interface for an admin and another interface for standard users. You're messing around in the standard user world, and then you think, right, I'm going to jump into admin, completely different application, but accesses the same data. And that's where I've rendered it. And that's quite often where I've struggled to think, got to go back to client now and look where that low priv user injection was.
Yeah, and that's massively fair comment, because that's a really nice way of achieving that privilege escalation through cross-site scripting instead of just taking over a generic user session. Again, anecdotally, when I've been doing it, it's been one application with multiple user levels as opposed to multiple applications reading the same data lake or data source. So it's not something I personally come up against, but I can completely understand the challenge of trying to focus where what actual payload triggered that. If an admin is able to read only specific parameters from a normal user, which one was it? And I think if you know that you've got multiple parameters that have the ability to be injected into, there's definitely got to be that importance of making sure that you understand what the payload is for each parameter, and even things such as trying session hijacking, turning around and having payloads like plus C equals plus document.cookie plus D plus document.cookie, so that you can turn around and be like, right, if this suddenly comes back with an admin session token, or this suddenly gets executed somewhere, I've got that ability to understand how this was achieved and which parameter forward this on, or which bit of data is being shared across multiple apps.
So does your tool for that payload creation add randomization into those payloads? Or
not at the minute.
Doing?
It's something that I'd look at doing, but at the minute it's very much focused on the obfuscation of data and taking things like script alert 1 and going, right, try all the different variations of alert, try lots of different variations of script, let's encode that in base64 and put that in a payload for a URI, let's encode that in ASCII and put that in a string from char, so that you can turn around and say, right, I have one payload that I'd like to try, here's lots of different variations. There's massive room for evolution of that tool. But at the minute, it will take the specific payload that you're trying and give lots of different variations. If fundamentally, script is recursively checked for that, it will not work, and it will wait for you to turn around and make attempts to say, well, what about image on source, blah, 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 and turn around and go, right, here are, again, data URIs, ASCII encoded, different HTML5 elements like audio and video that I've had a lot of success with, and it will give you that kind of list of different payloads that can be worth a try. Thank you. Yep.
Protections was putting up content security policy.
Yep.
In your experience doing like web app pen testing, how many companies actually go through the process building a comprehensive CSP? I
mean, in a phrase, not enough. This is such a nice way of being able to turn around and say, do not load things that are from untrusted resources. Do not just allow anyone to be able to have things execute on a browser. And it's something that I just haven't seen the adoption rates get to the point where it's actually useful to protect applications.
Isn't it we've got about 18 months to 2 years to get it in for PCI DSS version 4? Because it's being mandated now, I think, for when it fully comes in with all the new stuff in there to beat MageScript and things like that. I
mean, I'll be honest, I'm massively fortunate enough I haven't had to deal with PCI for about a year and a half now. So I can't comment on the new standard. But if the deadline's coming, then hopefully we can just hope that developers start taking notice. Okay. All right, well, thank you very much. I will hand over to the next talk.